Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on embedded systems. Today we are mainly discussing about on pin diagram of 8051 microcontroller. Okay, first if I see 8051 microcontroller, I can see only the two sides having the pin. That's why we are calling it as 8051 is a dual inline package. And how to denote all the pins we'll discuss now. First we need to identify the notch. From the notch, the left side is my first pin. From that, 1 to 20 is my left side, 21 to 40 is my right side. Okay, this is the way we need to represent our pin numbers. Okay, next one we need to draw one S here. Okay, this is my port 0, this is my port 1, port 2, port 3. This is the way we need to identify the ports locations. Okay, next one, here each port having 8 pins, totally 32 pins are covered. Next we'll discuss how to denote the remaining 8 pins. Okay, here 20 is my ground and 40 is my VCC. Okay, again two pins are over. Only I have 6 pins left. Okay, the right side EA bar, ALE and PSEN bar. Okay, in between this port 0 and port 1, we need to mention here EA bar, ALE, PSEN bar. This is for the external memory accessing. Okay, next one is in between port 1 and port 3, we need to represent the reset. Okay, finally crystal 1, crystal 2. If I want to connect any external crystal oscillator so that I can use this 18 and 19th pin. Okay, totally this remaining 8 pins 2 plus 3 here 4, 5, 6, 7, 8. Okay, 8 remaining. Okay, this is the way we need to represent our pin diagram. Okay, next one we'll discuss each and every pin functionality. Okay, first one is the port 1. Okay, port 1 is only we are having the input and output functionality. Either we can connect a switch or LED or LCD. For that purpose, we can use this port 1. Okay, there is no special functionalities, just it is a input and output functionalities. Okay, next one is our reset. Okay, if I want to start from the execution. Okay, for example, if my microcontroller is at the execution at the 1000 memory location, I want to reset back to 0 so that I can use this reset pin. Okay, next one is port 3. Initially port 3 we can use input and output functionality, and also we have some special functionalities also. For example, in my application use case, we have the transmission and reception also, so that I can use this TXD pin and RXD pin. These two we can use. If I want to transmit the data serially, so that I can use this TXD pin. If I want to receive the data from external device, so that I can use the RXD pin. For example, if there is no serial communication, these two pins we can use for the input and output use case. Okay, next two pins are interrupt 0 and interrupt 1. Port 3.2 and 3.3 are interrupt 0 and interrupt 1. For example, if I want to do any service upon a external interrupt, so that I can use these two pins. Okay, on any clock or clock change or any edge triggered, so that we need to do any external service, so that I can use this interrupt 0 and interrupt 1. Okay, next one is timer 0 and timer 1. This port 3.4 and 3.5, timer 0 and timer 1. Okay, we have two timers in our 8051 microcontroller. If I want to use this for the counting application, I can use this T0 and T1. In case of timer 0 for counting application, we need to use this 3.4 timer 0. In case of timer 1 counting application, so we need to use this 3.5 T1 pin. Okay, this is mainly for the counting applications. We need to use these two pins. Okay, next one, read bar and write bar. Okay, mainly if I want to access any random access memory or data memory, we need to use read and write. Okay, otherwise there is no use case of the read and write. For in case of program memory or read only memory, this read or write pins are not required. Okay, only to access any external memory we are using these two pins. Otherwise, input and output. Only we can connect switch or LED. Okay, next two pins are as we discussed, we need to connect external crystal oscillator to give the specified external clock frequency. If I want to operate this microcontroller, we need external clock frequency. Okay, next one is ground, and 40 is VCC. We need to give the 5 volts power supply to this dual inline package. Okay, next one, port 0 to port 0.7, port 0.0 to port 0.7, AD0 to AD7. We have address and data lines. Okay, for example, if I want to demultiplex this address and data lines, I can use the ALE. Okay, for example, I don't have any external memory use case, so that this port I can use for the input and output use case. Okay, here the mainly pull-up registers are not connected in the this port 0 initially. That's why we need to connect externally to use this port 0. Okay, initially this all three ports having the internal pull-ups, and this port we don't have any internal pull-up. Then we need to connect external pull-up resistor to use this port. Okay, we will discuss why we need this pull-up resistor in the next slides. Okay, here we want to discuss initially we can use this port input and output, and if I want to just connect any external memory, so that I can use these 8 pins for the address and data functionalities. For example, here main use case, if I want to read the data from memory or write the data memory, write the data to the memory, mainly we need first we need to identify the address. That's why I will send the address first, and after that I can read or write the data by using these pins only. Okay, that's why here address and data lines are multiplexed here, so that I can use both the use cases. First I will send the address, I can use A0 to A15, and after that D0 to D7 I can use the data read or write operations. Okay, mainly that is the use of this AD0 and AD0 to AD7. Okay, next EA bar external access. Okay, for example, here I just connected to the ground mains. Okay, I'm just accessing the external memory. Okay, if I'm not connecting any external memory, this will be VCC. Okay, this is the active low. Whenever it is ground, then my pin will be activated. Then I am able to access the external memory. EA bar is active low. If I am just supplying the ground, it is active. That means I am just accessing the external memory. Okay, next here ALE address latch enable. As we discussed here, if I want to demultiplex this AD0 to AD7, I'm using this ALE. Here see ALE is connected to the this G pin of our 74LS373. This is our latch. Okay, this address latch enable. Here I am just giving the pin. Okay, here I can demultiplex address and data line separately by using this ALE. First, I can mention the ALE is 0, so that I can access the address lines. Next, ALE 1 means I can just decode the only the data lines. Okay, this is a way we can use the demultiplexing of this address and data lines. We are using this ALE. Okay, next one is program store enable. This is mainly for the read-only memory. Okay, this PSEN bar mainly used for the read-only memory. This read and write bars are used mainly for the random access memory. Okay, read and write bar. Here only the PSEN bar we are using for the external program memory. It will be connected to OE pin of our ROM memory. If I want to just mention that I am using the external memory, this pin will be used. Okay, ALE we discussed, EA bar we discussed. Okay, next is the last port 2. Okay, initially we can use the input and output applications. For example, if I am just connecting any external memory, so that I can use for the addressing A0 to A15. Okay, here we have 16-bit addressing and 8-bit data. Mainly our 8051 controller has 16-bit addressing and 8-bit data. That means externally we can access up to 64 kilobytes. 2 power 16 means 64 kilobytes of memory we can access either ROM or RAM memories. For example, in our controller have 128 bytes of RAM and 64 4 kilobytes of ROM. Okay, we have only limited memory in our 8051 microcontroller. If I want to access any external memory like 64 kilobytes of RAM or ROM, so that I can use these two ports and also these two pins. Totally this 8, 16, 17, 18, 19, 20, 21 pins we need to use if I want to connect any RAM or ROM memories. Finally, this many pins we need to use. For example, if I want to use any read-only memory, only PSEN, ALE, and these two ports and EA bar. Only these three pins, 16 pins are required. 16 plus 3, 19 pins are required. If I want to access a random access memory or data memory, so that we need to use 2, 3, 4 plus 16. Totally 20 pins are required. Okay, these are mainly difference between the RAM or ROM accessing. Okay, mainly if I want to access memory, then we need to use this completely right side plus these two. Okay, remaining all other pins we are using for other purpose like transmission or reception, interrupts, counting applications, and here for the external clock frequency is the ground or VCC and reset. Okay, this is our mainly pin diagram we need to remember, and always we need to know the each and every pin functionalities. Okay, next we'll discuss the reset pin. As we discussed here, we need some external circuitry to do a power on reset and also manual reset. Okay, we will design one circuitry here. Just I designed with resistor and capacitor. Just I am giving the 5 volts to this circuitry. Just I am just turning on my power supply. Then here I will get the 5 volts here to here. Okay, initially my capacitor charge is 0. That's why I will get the 5 volts at the resistor. That's why this whenever the active high, microcontroller will be reset. Okay, it will be at least 5 machine cycles. That means our microcontroller will be reset upon a power supply. Okay, after that, after some time, my capacitor will be charged to max 5 volts. Okay, here my 5 volts are at the capacitor. Okay, after that, my resistor having the 0 volts. After that, there is no reset. Once the power is on, my microcontroller will be reset due to the resistor voltage is very high. It is equal to 5 volts. That's why my microcontroller will be reset. After that, capacitor keep on increasing. My resistor voltage will be decreasing. Okay, finally it will be falls to 0. After that, there is no reset. Okay, initially my reset pin will be high, and after few milliseconds, my microseconds, my capacitor will be charged. My across the resistor voltage will be dropped to 0. Then there is no further resets. That's why this circuit we are using for the power on reset. Okay, if I want to use the manual reset, so that I need to connect external one push button switch. Whenever I want to do a reset, for example, whenever my program counter is 1000 H, okay, my program execution at the 1000 H, I want to get back to the 0 so that I can give the manual reset. Okay, this is this two for the power on reset, resistor and capacitor. If I want to do any manual reset, so that I can use this push button switch. Whenever we want, we can just press this push button switch. This is the mainly use of this power on reset circuit, and also this is the only the external switch for the manual reset. Okay, whenever the reset is happened, my program counter reset to 0, and also accumulator, B register, PSW all are reset to 0, and stack pointer will be always located with 07H, and DPTR also 0, and all ports will be loaded with FF. Okay, initially this we need to remember. All ports will be mentioned with FF means 8 ones means all 8 pins will be writing to 1. Okay, if I am writing to 1, always my 5 volts will be connected to 5 volts. Okay, all ports initially upon a reset, my initially what is my port conditions, all are FF means if I just connect the LED, that will be turned on. Okay, that we'll discuss in the practical sessions. Okay, right now just we need to understand all ports will be FF means all port pins. FF means 8 ones, 1 1 1 1 1 1 1 1 1. Okay, totally 8 ones means, okay, each pin having the VCC 5 volts. One means logic, one means 5 volts. That means each pin having the 5 volts. That's why here all 32 pins we are having the logic FF. Okay, here initially all the LEDs will be turned on. If I just connect the LED, that will be turned on. Okay, initial all the ports with FF. Okay, here the just we need to remember stack pointer and all ports will be other values, and the remaining will be all the register will be reset to 0. Only stack pointer with 07, all ports with FF. This is our initial upon a reset. Okay, next one we'll discuss more on the machine cycle. Okay, here this is our clock frequency. Let us assume I am just giving the 12 megahertz. Okay, here this 12 megahertz, this one high to low, I am just mentioning it as P1 and P2. Next high to low, two high to low, I am just considering it as state 1. Okay, 12 clock cycles, I am just mentioning it as 6 states. Okay, to every 2 clock cycles, I am mentioning it as state 1. Okay, finally 6 states I am mentioning with the one machine cycle. Okay, if I want to calculate the one machine cycle timing with 12 megahertz, we'll calculate here. Time period of one clock cycle equal to 1 divided by frequency, 1 divided by 12 megahertz, 1 divided by 12 microseconds. Okay, here one t state equal to 2 clock cycles. Okay, this is a one clock cycle, one high to low, one more high to low, one more clock cycles. That's why 2 clock cycles. That's why I'm just multiplying with 2 if I want to get the t state. Okay, here S1 state if I want to get, that's why I'm just multiplying with 2. multiplying with 2 with 1 divided by 12, so that I will get 1 divided by 6 microseconds. Okay, this is my one my now I need to calculate one machine cycle with 60 states. Okay, that's why I'm multiplying with 6. If I want to calculate the machine cycle, that's why I'm just multiplying with 6. Okay, finally 6 multiply 1 divided by 6, I will get the 1 microseconds. Okay, if I am giving the 12 megahertz, my machine cycle period is 1 microseconds. Okay, similar way we'll calculate with other examples. 11.0592. If I am giving the external frequency of 11.0592, okay, then how to calculate the machine cycle easily, then we'll discuss here. Okay, the frequency divided by 12. This is my first frequency, 11.0592 megahertz divided by 12. I will get the 921.6 kilohertz. Okay, here the machine cycle equal to 1 divided by frequency, then I will get 1.085 microsecond. This is the way we need to calculate the timing of the machine cycle. Okay, similarly for other frequency divided by 12 equal to 1.3333 megahertz. Okay, similar machine cycle equal to 1 divided by frequency 0.75 microseconds. Okay, if we have any micro frequency, so that we can calculate machine cycle easily by using these formulas. Okay, here mainly this 18th and 19th pin. Okay, already we discussed with the reset pin. This 18th and 19th pin we need to connect external crystal oscillator. Okay, here I'm just giving the mainly we will use our microcontroller 11.0592 megahertz. Why? Because if I want to mainly work on the serial communication, if I want to match with the PC baud rate 9600, okay, we are achieving with this 11.0592 megahertz. That's why we are using mainly on our 8051 microcontroller. We are always feeding with 11.0592. Okay, this much of frequency we are operating with our 805 microcontroller. This we need to remember always, 11.0592. Okay, this mainly we'll discuss in the serial communication in further sessions. Okay, here the port logic will discuss. For example, each port having this much logic circuitry inside. For example, if I want to write one to the particular port pin, we'll discuss what is our output functionality. For example, here we'll discuss mainly on writing. Okay, reading, just we'll forget this read latch and read pin. Okay, this will forget now. Tri-state buffers are not required in case of writing. Okay, here I'm writing one to the pin from the internal bus from the microcontroller. I'm just writing to the one here. For example, let us assume port 1.0. I'm just writing one to the from the CPU. Okay, here I'm writing one to here. I will get the latch output. Okay, here write to latch. I'm just giving the, let us assume I'm giving one here, so that my I will get the one output from as it is whatever I'm giving the input, that I will get the output here. Q bar is that complement. One means zero. Here zero means this switch will be open. Okay, here pull up, as we discussed in the initial pin diagram, this port 0 we don't have any pull up. Okay, this pull up resistor we need to connect externally, otherwise it will be open drain. Okay, that's why this port 0, this resistor we need to connect externally. If I want to use the port 0, we need to connect this external pull up resistor, otherwise this should not be used. Okay, next here I got the 0 volts, that means switch is open. I will get the VCC 5 volts to the output pin. Okay, here that means if I just connected the LED, then my due to the 5 volt my LED will be turned on. See, if I am just writing to the 1, I will get the output voltage with 5 volts. Okay, similar we will discuss writing 0. Okay, here I am just writing to 0. I am just giving the large right large to 1. Okay, here I will get the, as it is 0. 0 complement is 1. 1 I am giving to here. Okay, it will be connected to the ground. Now the switch is on. It will be connected to the ground. I will get the output is ground. Ground means 0 volts. Okay, here the 0 volts means LED turn off. Okay, the pin output will be 0. Okay, here if I am giving the from the microcontroller, if I am giving the logic 1 to here, my output voltage is VCC. If I am just giving the output pin voltage to 0, my output is 0 volts. Okay, based on our logics, this pin will work upon the logic. Okay, here just if I am just writing the logic 1, I will get the VCC at the output pin. Similarly, if I am just writing to 0, I will get the output voltage is 0 volts. Okay, this is connected to ground due to this logic circuitry. Okay, we need to understand in the next programming, if I'm just writing to the particular pin to the 0, I will get the 0 volts to the that particular pin. If I'm just writing to the 1, I will get the VCC. Okay, The next one, reading high at the input pin. For example, for the reading purpose, we can use this tri-state buffers. TB1 and TB2 are tri-state buffers. We are not discussing this writing applications. This is the mainly we are using for the reading applications mainly. For example, this tri-state buffer here, similar way I'm just writing to the one to this pin. Okay, I will get the one output. Here latch I'm just always giving one, so that this one complement is 0, my switch is open. Okay, here always 1. Okay, this whenever I am just giving the high to the pin, whatever the high voltage will be received to the tri-state buffer. Here I am just read pin, I am mentioning it as 1. This is our enable pin of our tri-state buffer. For example, whatever the input value, if I want to get to the output, this enable pin should be high. Here I am read latch is 0. Here I am just not discussing more on the here. Why? Because this enable pin is 0 means this won't be a feedback to the input. Okay, there is no connection, this is open circuit. 0 means enable pin is 0, there is no input to the output. Okay, here the read pin is 1 means whatever the input voltage will be feedback to the output. Okay, here similar way I'm just mentioning it as read pin is 1 means whatever the input voltage will be coming to the CPU. Okay, this is a way we can read the data from the external device. Okay, similar we will discuss how to write. Okay, similar way I'm just writing to the from the bus, I'm writing to the one value, I will get the one. Okay, one component is 0, my switch is here 0 means open. Okay, next here whatever the input voltage will be coming to here, anyway the read pin is 1. Here whatever I am just giving the low active low here, I will get the low to here. Okay, just I am giving the read pin is 1 means whatever the low voltage will be feedback to the input. Okay, whatever the as it is, whatever the 0 volts will be coming to inside, then that will be given to the CPU. Okay, this is the way we can use for the reading operations. In case of writing also we can use mainly for the reading and writing operations, so that we can use our port pins. Okay, that's all friends, thank you for watching, thank you.